Welcome to this demo of the Simulix SIM adapter for ArcGIS. Making ArcGIS data available for other systems is an absolute must for the modern utility. Advanced solutions for smart metering, predictive maintenance, asset optimization, outage management, etc. all relies on access to up-to-date GIS data. Today, SIP is a de facto standard in the utility industry for exchanging data. Thus, it becomes a requirement for the utility to be able to export GIS data on a SIP-based format. This is where the Simulix SIP adapter for ArcGIS comes into play. It is an advanced tool for defining the mapping of the ArcGIS data model into the SIP data model, and for making the actual orchestration of the mapping in the operational environment. To introduce the capabilities of the Simulix SIP adapter for ArcGIS, let us consider a simple example where we want to map a transformer from ArcGIS representation to a SIP representation. So, in real-life world, we have a pole-mounted transformer with one line in and two lines out. In ArcGIS, this is represented by a primary overhead line, a transformer, and two secondary overhead lines. Now we want to make a SIP representation of this transformer. At the right-hand side, you can see how the transformer with connections is represented in a simple SIP model. We have the AC line segments representing the overhead lines and the power transformer with associated transformer ends representing the transformer. In addition to this, we have terminals and connectivity nodes, which are SIP objects used for modeling electric connectivity. So, what we want to do now is to define a mapping of the transformer from the GIS representation to the SIP representation based on a predefined SIP target profile. To do this, we use the Simulix SIP adapter for ArcGIS. This is the Simulix SIP adapter for ArcGIS. What you see here is the user interface for defining the mapping logic. Before I start making my mapping, I need to specify the ArcGIS data that represents the source model. You can see that I have selected the ArcGIS database here, and below I can see the resulting feature classes. And I have also specified the SIP RDF file that defines the SIP profile that is my target data model. You can see I have the path to the SIP profile here, and below you see all the resulting SIP classes. Here, in my source definitions, I have selected ArcGIS source features that should be part of my mapping. That is primary overhead line segment, secondary overhead line segment, and transformer. Now I'm ready to define the mapping logic. To make it easier for you to follow the mapping process, I have inserted the model in the lower left corner of the video, where I will highlight what part of the mapping I'm working on. First step in the mapping is to define the various feature mappings. At the left-hand side here, you see the available GIS source definitions, and on the right-hand side here, you see the possible SIP target definitions. First, I map the GIS primary overhead line segment into the SIP AC line segment by making a simple drag-drop. Then I define an attribute mapping where the global ID attribute in the GIS is mapped into the MRID in SIP. If required, I could map many more attributes, but for now I just do this one. Now I want to define the connectivity. I click the Has Terminals checkbox, and then this table specifies that the AC line segment has two terminals, one at each end of the line, and then all feature mappings can connect to these terminals. With running the mapping, the terminals and the associated connectivity nodes will automatically be created. Beforehand, I have made the other feature mappings that are required for this simple example. The mapping of the GIS secondary overhead line segment into the SIP AC line segment is straightforward and similar to the mapping of the primary overhead line segment we just created. The mapping of the transformer is a bit more complex, as I need to make 3 different feature mappings. The first one is from the GIS transformer to the SIP power transformer. Again, we have specified 2 terminals, but in this case we differentiate between them. We have the high-end terminal, where only primary line segments are allowed to connect to, and we have the low-end terminal, where only the secondary line segments are allowed to connect to. By doing so, we have full control over our connectivity mapping from GIS to SIP. The other 2 mappings are from the GIS transformer to the SIP transformer ends. I have made 2 feature mappings to be able to distinguish between high-end and low-end, here indicated by the naming convention. As the transformer end is not a conducting equipment in the SIP model, I have not checked the Has Terminals checkbox. So, now the feature mappings are in place, and all that remains is to make the association mappings to secure that we have the correct associations between the SIP power transformer and the SIP transformer ends. The first association mapping is from the high-end transformer end to the power transformer. I create the mapping by dragging the high-end transformer end feature mapping to the power transformer feature mapping. First, I define the association property. In this case, it is a power transformer association. Then I specify that it is an attribute-based association and that the association is defined via the global ID attribute. The second association mapping is from the transformer end to the power transformer terminal. As I am mapping the high-end transformer end, I select the high-end terminal of the power transformer. Again, I specify the association property, here being terminal, and I specify that the association is defined via the global ID attribute. So, now I have made this basic transformer mapping, and I want to run the mapping and create a resulting SIP XML file. I've specified my output file, and I have narrowed the mapping down to only cover a very small geographic region. As you can see, I could also have defined that I wanted to map all GIS objects related to a specific feeder. So, now I run the mapping. And this is the resulting SIP file. As you can see, the various SIP objects have been created, including connectivity nodes, terminals, and their associations. This concludes our simple mapping example, where some of the mapping capabilities of the Simulink SIP adapter for ArcGIS have been demonstrated. The next step would then be to incorporate this mapping logic in the operational environment. For this purpose, the Simulink SIP adapter comes with elaborate orchestration capabilities, where services automatically detect changes in ArcGIS, create ZIP files for affected objects, and export the files to predefined destinations. As you have seen, the Simulink SIP adapter for ArcGIS is a simple and efficient tool for making your ArcGIS data available on ZIP formats. It comes with a highly intuitive user interface for defining the mapping logic, and it provides advanced service-based functionality for orchestrating your ZIP mapping in the operational environment. Thank you for watching this demo. If you want to know more about Simulink, the Simulink SIP adapter for ArcGIS, or other Simulink products, please do not hesitate to contact us.